We're looking at solving logarithmic equations. In the past clips, we have been looking at the different laws of logarithms. We have used the laws of logarithms to simplify different logarithmic expressions. Now we are going to look at equations that involve logarithm. And to do this, right on our screen, we have 5 questions where we have to solve for the various unknowns. Question 1 to question 5. In this video clip, we will take care of question 1, 2, and 3. And in the next video clip, we'll take care of questions 4 and 5. To do this, we'll have just beside us all the laws that we have considered so far. And there they are, the first to the fifth. And we'll see how these laws will help us in solving all these equations. Let's start with question number 1. Question number 1 states that we should solve logarithm of 3x minus 4 to base 10 minus logarithm of 2 to base 10 equal to 1. First and foremost, I look at the minus sign here and I try to apply this rule that says that the log of m minus the log of n is equal to the log of m over n. So I express the left hand side as a single logarithmic expression by writing the log of 3x minus 4 divided by 2, which is like my n, of course, to base 10 equal to 1. Now after writing this, I have a logarithmic expression here, but I can convert this to an exponential equation by saying 10 raised to the power of 1 will be equal to what? 3x minus 4 over 2. So I say, okay, 10 raised to the power of 1 is equal to 3x minus 4 all divided by 2. First, let's write this out neatly. So that's it there. Now we have a very simple equation here. We stopped there. 10 raised to the power 1 is equal to what? 10 raised to the power of 1 is equal to 3x minus 4 all over 2. And of course, 10 raised to the power 1 means 10. I can look at this as 10 over 1. And I cross multiply. If I cross multiply, 1 times 3x minus 4 will give me 3x minus 4. And 2 times 10 will give me 20. Rearranging these, I have 3x is equal to 20 plus 4, which is 24. So I have 3x equals to 24, and of course we can solve from here that x is equals to 24 divided by 3, and that will give us 8. And that's it there. So we have been able to go through the first one. How did we do this? Let's take it very fast. The left hand side, we had 2 logarithmic expressions. We combine the 2 of them to form 1 by applying the second rule there, because we have a minus sign here. So we simply say the log of what? 3x minus 4 divided by 2 equals to 1. And then we move from there and say, okay, let's change this to an exponential expression by saying 10 raised to the power of 1 is equal to 3x minus 4 all over 2. And that led us to this. And from there, we'll cross multiply it and solve for x, which gave us 8. Let's look at the next question. This one says that 5 log y plus 3 is equal to log 32. I look at 32 and something tells me I can get 2 raised to the power 5. And I look at the left hand side, I see 5 standing at the back of the logarithm. And I remember this law. I say, okay, maybe I should move the 5 inwards. That is, right now my 5 is standing there. I can make it to look like the left hand side. So I say, okay, instead of writing this as 5 log y plus 3, I can simply write this as log of what? Y plus 3 all raised to the power of 5. And I said, if I can do that, why don't I just write my 32 as 2 raised to the power 5? Now I have both sides looking very similar. I have an expression here, y plus 3 raised to the power of 5. I have an expression here, 2 raised to the power of 5. If both sides are equal, common sense will tell me that it means that y plus 3 must be equal to 2. And of course, from here, I can simply solve for my y. That y is equals to what? 2 minus 3. And that should give me minus 1. That was a very straightforward one. So that's it there. Moving the 5 up. And then by the next slide, you can see we now have 2 raised to the power 5. Comparing both sides of the equation, we're able to arrive that y plus 3 equals to 2. And then we solve for y and we obtain y as minus 1. Let's look at the third one. Question number 3. Question number 3, I think, is a piece of cake, so straightforward. We have log x squared to base 3 equals to minus 4. I can just convert this to what? An exponential equation by saying 3 raised to the power of minus 4 is equal to what? X squared. Okay? 3 raised to the power of minus 4 is equal to x squared. And I apply my little knowledge of indices. And then this is the same thing as 1 all over what? 3 raised to the power 4, which is what? X squared. And you agree, this is 1 all over 81 equals to what? X squared. Taking the square root of both sides, that's it there. 1 over 3 raised to the power 4, which is the same thing as 1 all over what? 81 is equal to x squared. Of course, if I take the square root of both sides, I can say, okay, the square root of 1 all over 81 will give me x, which means my x is therefore 1 all over 9. So that's it. For the first 3 questions, you can see how the laws of logarithms combined with our knowledge of indices has been used to solve what? 3 logarithmic equations easily. By the next slide, we'll take questions number 4 and number 5.